Magis Day students, it's me, Miss Morales, and in this video, you will learn how to apply the different laws of exponents in multiplying monomials. Alright, before we proceed with our short discussion, let us do a quick review on laws of exponents. So for numbers 1, 2, and 3, this is where we apply the exponential notation. Now, notice that in number 1, 8 is squared. No? So 8 squared. And that basically means you have to multiply the base 8 to itself twice since the exponent is 2. So that will be 8 times 8, and that will give us a product of 64. Now, same thing applies with number 2 and 3. But it is just that for number 2, the base 3 must be multiplied to itself 4 times. So that will become 81 since it's 3 times 3 times 3 times 3. And for number 3, that's 121. Now, let's proceed with number 4. Take note that for this case, no, we have to apply the product rule because the operation is multiplication, and we also have here a common base of 8. Now, this time, we are going to keep the base and add the exponents, which will give us a result of 8 to the power of 7. Same concept applies with number 5, and that will give us m to the power of 9. While for number 6, we have here 4 to the power of 3, the quantity of 4 to the power of 3 squared. So we have here two powers, all right? And this is where we apply the power rule, which states that we have to multiply the two powers. So this will give us then a result of 4 to the power of 6. And for number 7, we have here x to the power of 8 because 2 times 4 is 8. Alright, how about for number 8? Take note that for number 8 class, we have here a monomial, which is the negative 2, and then multiplied by a binomial, which is x minus 3. Okay, so that's basically monomial times a binomial. So in this case, we are going to apply the distributive property of multiplication, and it's over subtraction. Okay, so we are going to distribute the negative 2 outside the parenthesis to the terms inside the parenthesis. So it will become negative 2 times x, all right, and that will be negative 2x. And then negative 2 times negative 3, take note, remember, negative times negative, that is positive 6. So our final product will be negative 2x plus 6. Alright, now let's proceed with the discussion proper of this video. So remember that when you multiply powers with the same base, you just have to keep the base and sum up, no, or add exponents. So I have there an example shown. So x squared times x to the power of 3. You just have to keep the base since we have here common x, and then you add the exponents 2 plus 3, and that will give you 5. So final answer will be x to the power of 5. All right, now we proceed with multiplying monomials. Take note that in this case, we just have to apply everything that you have learned with the laws of exponents. Okay, so basically, more likely we will be applying here the product rule since it's multiplication. All right. Um, For letter A, we have here 6y to the power of 3 times 3y to the power of 5. So we have here two monomials. Uh, and in this case, we just have two group factors with like bases together. Okay. And since we have here y to the power of 3 for the first monomial and y to the power of 5 for the second monomial, we have to group them together since they have like bases or same common base. So we will have here 6 times 3. By the way, we have to put the coefficients together. We have to put the coefficients together. So we have here 6 times 3. We put them together and we multiply. Same goes with those factors with common bases. So we have here y to the power of 3 times y to the power of 5. All right, now we multiply the coefficients. 6 times 3, that is 18. And then y to the power of 3 times y to the power of 5, that is y to the power of 8. So we now have here the simplified form of 6y to the power of 3 times 3y to the power of 5, and that is 18y to the power of 8. Okay, same concept applies with example B. So we have here 3mn squared times 9m squared n. Right. So the quantity of 3mn squared times the quantity of 9m squared n. So again, we group together the coefficients and we multiply them, and the same thing also with those variables that are common, and we also have to multiply them. So this will look like 3 times 9, since these are the only two coefficients, and then m times m squared, and then n squared times n. Okay, so we got the variables from we have here m from the first from the first monomial, and then m squared from the second monomial, n squared again from the first monomial, and n from the second monomial. So we multiply them, we apply the product rule. So we have here 3 times 9, that's basically 27, m times m squared. So we keep the base m and we add exponents. Now notice class that for m we have here an imaginary exponent 1. So that becomes 1 plus 2, so that's 3. And then n squared times n, same concept, no? Since you don't see there a variable, take note that there is, in that case, there's an imaginary 1. So that will become n to the power of 3. So that's our simplified, our final answer for example B. Now let's proceed with our third example. We have here the quantity of 1/4 s squared t squared times the quantity of s t times the quantity of negative 12 s t squared. Now, in this example, it might look intimidating because of the fraction. I know what you're thinking, but I tell you, um, if you master the skill of multiplying monomials, this one will be so easy for you, because take note, you just have to group together the coefficients. So in this case, we have 1/4, and then for the second monomial, we have here 1 as its coefficient, and for the third monomial, we have here negative 12 as its coefficient. So again, we group together the coefficients. We now have here 1/4 times the negative 12. And then right after that, we group factors with like bases together. So from the first monomial, we get s squared. and then we also write it together with the s from the second monomial and the other s from the third monomial. So we now have here s squared times s times s. Now for t squared naman from the first monomial, we write it together with the t from the second monomial and the t squared also from the third monomial. So we now have here, we simplify everything. No, we apply what you have learned previously. So 1/4 times -12. So this is fraction times whole number times a whole number, and that will become negative, no? I mean, yes, positive times negative. Remember, that is negative 3. So why is it negative 3? Because 1 times -12, that is -12 divided by 4. So that is -3. Okay. And then we proceed with the other, I mean the variables. So we have here s squared times s. So that's basically keeping the base s and then adding all the exponents. So 2 plus 1, and that is 4. And then the same concept applies with variable t, no? So t squared times t squared. So that's keep the base t and add the exponent. So 2 plus imaginary 1 plus 2. So that is 4. So if we're going to simplify the given, which is the quantity of 1/4 s squared t squared times the quantity of st times the quantity of -12 st squared, we have here the product -3s to the power of 4 t to the power of 5. All right. All right, so I have here additional examples, more examples if in case you might need more to review, to study with. And for letter A, we have here the quantity of 3x to the power of 3 times the quantity of 6x squared. So basically, again, in this case, we write together the coefficients and we multiply them. And the same concept applies with the variables, since we have here common variable x. Okay, so we have 3 times 6. All right, there you go. And then x to the power of 3 times x to the power of 2. And then we simplify, take note, 3 times 6 is equal to 18. And applying the product rule of coefficients, so we have here x to the power of 3 times x to the power of 2. That's basically keep the base x, and then you add exponents 3 plus 2, and that is 5. And for B naman, we have here, again, write the coefficients together. We have the first coefficient 2, second coefficient 5. So 2 times 5, that is 10. And get the r squared from the first monomial. And since there is no variable r on the second monomial, then it goes alone. Okay, there's nothing for you to um to multiply it with. So it's just r squared. And then let's proceed with t. When we proceed with t, we have here t from the first monomial and t cubed from the second monomial. So we multiply them, we keep the base, and we add the exponents. So basically our final answer would be 10 r squared and t to the power of 4. I mean 10 r squared t to the power of 4. All right, so we have here another example involving a fraction. And in this case, we just have to apply, what you have learned in the previous slides. So we write together the coefficients from each set of monomial. Then same goes with the variables that are common, no, among them. So we have 1/3 from the first monomial, 12 as the numerical coefficient of the second monomial, and for the third monomial we have here 1. But actually, we don't have to put 1 with the 1/3 and 12, because remember, no, anything that you multiply with 1, well, it's just itself. So 1/3 times 12, and then we have here the x squared from the first monomial. Then we also get the x to the power of 3 uh, from the second monomial, and the y also from the first monomial, and the y to the power of 4 from the third monomial, and z to the power of squared from the second monomial, and z to the power of 5 from the third monomial. So you just have to be very careful in identifying what are common, no, common variables between each set of the monomials, each set of the terms. So we now proceed with multiplying. 1/3 times 12 is actually equal to 4. X squared times x to the power of 3. Take note, we just have to keep the base. Since it's multiplication, we apply the product rule. So we keep the base and add exponents. 2 plus 3, that is equal to x to the power of 5. And then same goes with y. Remember, there's an imaginary 1 on top of that y. So 1 plus 4 is y to the power of 5. And z squared times z to the power of 5. So that is z to the power of 7. So we now have here 4x to the power of 5, y to the power of 5, and z to the power of 7 as the simplified form of the given. All right, so this ends my discussion for this video. I hope you have learned a lot regarding multiplication of monomials. I'll see you in my next video.